Let's look at this example. The IQs of 550 applicants to a certain college are approximately normally distributed with a mean of 117, and a standard deviation of 14. Okay, so let me get this here. The college requires an IQ of at least 95. How many of these students would be rejected then, based on this basis of IQ? Note that IQs are recorded to the nearest integers. There's some interesting details with this question. The first of which that I want to just kind of talk about is the idea that IQs are recorded to the nearest integers, but the normal distribution is approximately normally distributed. The normal distribution is continuous. Okay, so IQs are recorded to the nearest integers. So essentially what we have here is we're using the normal distribution on a discrete problem. We're using a continuous distribution on a discrete problem. So let's think about the impact that this might have. We have a mean of 117 here. So my IQs of the 550 applicants, we have a mean of 117 and a standard deviation of 14. We're looking for an IQ of at least 95. All right, so let's think about what would be acceptable here. Okay, so let me go ahead and draw this. Normal distribution with a mean of 117. So let's just say 117 is right here. Just kind of get a sketch of our normal distribution there. All right, so maybe that's our normal curve in this case. Now, we were requires an IQ of at least 95. So if 95 is right here, there we go, we would be rejecting everything below it. We're going to get rid of everything down here, right? So we want to know essentially the probability that an applicant is in this rejection area, right? We want to know the probability that an applicant is within this rejection area, so we would sort of start by looking at the probability that X is less than 95. Probability that X is less than 95, okay? But so here's the sort of thing about this, then, I guess. If you think about zooming in right here, IQs are recorded to the nearest integers. IQs are recorded to the nearest integers. So let's say someone has an IQ of 94.6. Someone has an IQ of 94.6. Well, a 94.6 would actually move to a 95 if it's recorded to the nearest integer, right? So our rejection area here, we don't want to reject the 94.6. We should not be including this area right here. We should not be including that area in our rejection area, all right? So what we were going to do here is actually we're going to be looking at the probability. What do we want here? Since it's recorded to the nearest integers, we'd want the probability that X is, what would we want here? Less than 94.5. If you're less than 94.5, you would round down to a 94. Right? Okay. And that's a small detail that may or may not actually matter in terms of our end result, because we're talking about applicants of humans, and so it might not affect our rounding to the nearest, whole number in terms of the number of applicants. We're not going to reject 0.3 applicants, right? So that may or may not be a big deal. I would say we can take a comparison here and look at both of those cases, but just something to think about. This is the common thing we'll be working on as we move forward and use the normal distribution to approximate other things. When you're looking at discrete cases, you kind of got to look at those plus or minus maybe a half unit or something like that. Because, again, a 94.6 would get rounded up to a 95, okay? So that could have a small impact. So let's go ahead and work with this. Probability that X is less than 94.5, then we can convert this to a standard normal distribution question. We have a mean of 117, so we can subtract the 117 divided by 14 there, divided by the standard deviation. And so this is the probability then that a standard normal random variable is less than, what is 94.5 minus 117 here, divided by 14. I have got negative 1.6071. Negative 1.6071, which is pretty close to negative 1.61. Pretty close to negative 1.61. So let's go ahead and take a look at what that is in our table if we can real quick, yeah? Let's see here. Got to get our probability table out. And here we go. What did I say? Negative 1.61. Here's negative 1.6. 1 is about 0.0537 right there. 0.0537. Let's zoom in so we can read that better. 0.0537. 0.0537. So let's go ahead and work with that. So this is approximately 0.0537. 0.0537. So what does this mean? This is our correct rejection percentage. This is for an individual, right? You have 550 applicants, okay? The distribution of those applicants is approximately normal with a mean of 117 and a standard deviation of 14, okay? So we expect about 5.37% of those applicants to be in that rejection range. So how many applicants are we going to reject? We can take our total number of applicants, which is 550, times the probability that we would reject an applicant according to this distribution. So 550 times 0.0537 is 29.535. 29.535. That's a pretty close cutoff in rounding to 30 versus 29. That's a pretty close cutoff in rounding to 30 as opposed to 29. So we actually would be rejecting 30 applicants. We'd be rejecting 30 applicants. That is the correct response here because these are recorded to the nearest integer. Because these are recorded to the nearest integer. Okay. I'm wondering if we don't keep track of this detail and we just dive into this naive approach and think of the IQs being reported as a continuous number, if that changes our rounding. So maybe let's go ahead and think about that real quick. So I need to scroll down here. So we're looking, what if we say probability x is less than 95? What if we accidentally just looked at that? How would that change things? So if we did this, we would be looking at the probability then. Let's convert this to our standard normal question. That would be 95 minus 117 over 14. And 95 minus 117 divided by 14 is negative 1.571. Negative 1.571. So we're going to look for negative 1.57 in our table. Where is negative 1.57 here? Negative 1.50, 1, 2, 3, 4, 5, 6, 7 is 0.582. 0.0582. 0.0582. 0.0582. So what is 550 times 0.0582? That is 32.01. 32.01. That's a big difference. That's an extra 2 people that we'd reject. That's an extra 2 people that we reject. You got to be careful here. Careful. This is not correct. That is not correct. Okay, because the scores are reported to the nearest integer, we need to think about it as an integer in the sense that a 94.6 would count as an acceptable score that is a 95 in terms of the IQ that's being reported, okay? So be careful on those details. That's 2 extra people that we would be rejecting. You might say 30 or 32 out of 550. That's roughly the same amount. I would beg to differ, especially if you are one of those 2 students who normally would not be rejected.